The disposal of waste is a daily problem and a changing problem. This is the city of Newcastle in the heart of Tyne and Wear. Like every other city, like every other region, it has its own type and mixture of waste. It varies between districts and it varies between streets. From residential areas, we get household waste, paper, metal, wood, plastic and glass. We also get ashes, dust, scraps of food, all the throwaway debris of modern society. And of course, we get it in large volume and every day. Apart from household waste, there are two other varieties. First, there's commercial waste, the waste from our shopping districts, hotels and offices. To the expert, it belongs to a different category of waste. It contains larger proportions of paper cartons and other quick-burning materials. Then there's the waste from our places of work, shipyards, factories, warehouses, industrial waste. It might be paint, timber, rope. It might be refuse from your house, your supermarket, your factory. It might be anything and everything. You throw it away, we collect it and dispose of it. And until recently, there the matter stopped. Now, in the second half of the 20th century, we know better. The thoughtless destruction of material is quite out of touch with today's ideas for reclamation and recycling. Gradually, almost relentlessly since the turn of the century in Britain, we have sought ways to separate and recover from our waste materials of value. More than that, to convert waste into power. As early as 1900, some plants were already generating steam for electricity. Then we lost the way. It has taken 2 generations to rediscover it. Since then, our towns and cities have grown. There are more people, more houses, more factories and more cars. And of course, even more litter and more refuse to dispose of. Burning or incineration is certainly one technique for disposal, but its success is also its failure. The economics of incineration are opposed to any efficient form of heat recovery. It also reduces waste dramatically in volume, but little or nothing is recovered. In the clinker that is left, the raw materials are destroyed. So, incineration too is out of sympathy with our new thinking about reclamation. Against this background, in 1975, Tyne and Wear County Council took part in an experiment. With a consortium of companies that included the British Steel Corporation and the Metal Box Company, a method of extracting tin cans from crude refuse was developed. Combining conveyors and magnets, a high rate of metal recovery was achieved, and it was the first development of its kind in Britain. The experiment had shown that waste could be processed to recover valuable minerals, such as tin, steel, and aluminium. And people were now saying something else. Could waste also be a potential source of energy? About a year later, new trials began at a British Steel Corporation plant. The experiment this time was concerned with the calorific value of fuel derived from waste. Waste in pellet form was mixed with coal in a series of burning trials. Once again, the result was promising. What was needed, as on the first experiment, was an opportunity to build a large-scale plant. In this case, to produce sufficient pellets on a commercial scale to make energy recovery economic and viable. 2 pilot plants had shown that waste could indeed yield up metals and generate heat. Out of these discoveries grew another idea. What if it was possible to achieve these ends and, at the same time, make better environmental use of land sites? Instead of more eyesores like this, landscapes like this, the rising sun at Wall's End. Once a wasteland, now restored to use. With land for tipping not so available as it once was, any system of waste disposal that had the potential to recycle materials, provide power, and remove eyesores was indeed like the rising of the sun. In 1977, the opportunity came. A plant built to reclaim waste. The first municipally built plant of its kind in Europe. The Byker plant. An area on the eastern boundary of Newcastle was chosen as the site. As the steel skeleton took shape, there was nothing to indicate the significance of the development. It marked the start of a new era in modern waste disposal. A scheme, the first on a large scale, that would bring together under one roof all that was considered best in the processing of urban waste, incorporating refuse separation techniques, and providing a source of fuel. In the early stages, the project concentrated on the building shell. Later, it was the turn of the floor where the mechanical plant will stand. Even as the building progressed, new advances and improvements in reclamation technology were still taking place. Fortunately, the design allowed for the maximum possible flexibility between the work of the civil engineers on site and mechanical engineers off-site. In the Midlands, for example, a new machine to separate heavy and light materials by a system of air classification was under construction. Screening materials into different particle sizes is a new technique within the United Kingdom, although the principle of it, separating wheat from chaff, is more than 2,000 years old.
Well, as we said at the last meeting, Brian, the civil people, although they're trying to catch up with this 4 to 5 week delay, they're hopeful if we get a decent summer that they should be on programme. I don't know how much the delay is affecting your side, Jack.
Well, so far we're the kind of pre-ordering.
Pulling together individual units of design, meeting contract dates and delivery dates, all within the overall schedule of the building programme, involved close technical liaison and cooperation. With the building programme and the mechanical programme planned in parallel, more units manufactured off-site arrive for installation on-site. This is part of the pulverizer, a unit situated in the separation building in which the waste is first reduced by hammers at the start of the process. The site was surrounded by the community it was eventually to serve, the domestic, the commercial, the industrial. The transformation that was taking place on a small hillside in the heart of Byker had been planned with the wider environment in mind. It was surrounded, for instance, by housing, including terraced houses on the eastern perimeter. The noise factor had to be considered. Although bounded by a railway line to the south, the site would be fronting a major highway. This meant that it was ideally situated for integration with the local road network for the delivery of refuse. The structure looked like any other new building, but this was to be a reclamation plant, built not to destroy waste, but to reclaim from it. Inside the building, the plant was installed within a year and ready for commissioning. To the layman's eye, it presented a jumble of pipe runs and conveyors. To the more professional eye, it was a flow line. At Byker, the operation follows a sequence. Vehicles entering the site with refuse discharge onto a storage area. A mechanical shovel then feeds the refuse into the main process area. The refuse is conveyed into the pulverizer, where it's reduced to size. From the pulverizer, the refuse broken down is fed to a rotary screen where the fine material is screened out and hauled to landfill. At the same time, oversized material is removed. What is left, the feedstock, is conveyed to the air classifier for further separation into heavy and light materials. The heavy fraction, the green dots, includes ferrous metals which are magnetically extracted and baled. The residue, heavy rejects, is used for land reclamation. The light fraction, paper and plastics, is the eventual source of fuel. After winnowing and tumbling through the air classifier, it passes to a secondary pulverizer to be shredded and squeezed into pellets. At the end of the process, the pellets are cooled. They are then either stored for external supply or conveyed directly to the district heating boiler plant adjacent to the process area. The continuous cycle from reception to the various discharges is monitored from the high-level control room. Every day, the sequence is the same. Vehicles entering the site are weighed and proceed to the reception hall for unloading. Now, the material leaves the storage area and the process of separation begins. Let's follow the same sequence again, this time looking at the plant itself. The hammer mill, or pulverizer, reduces the screened waste to a measured size. Inside the rotary screen, the waste is separated. Two sizes are immediately rejected: the fine material and the oversized. The screened material that is left is a mixture of light paper and plastics and other heavier wastes. The feedstock now moves to the air classifier for further separation by a spiral of air. It's after air classification that metal is removed by magnets. Ferrous metal, about 7% of the waste input, is automatically weighed and baled. Each bale contains about 700 cans. The recoverable material value of waste can be seen now for the first time. The baled waste can be taken away, shredded, and then the steel and tin separated chemically. The process recycles tin cans back to tin cans. The melted tin is, in fact, reformed into ingots. Tin can reclamation is the first benefit from waste separation. The second is in the waste product from the light fraction after air classification. It is used in the making of pelletized fuel. The beauty of the Byker system is the final touch, moving the pellets direct by conveyor into the adjacent boiler house. The boiler is capable of burning coal, or pellets of waste-derived fuel, or blends of the two.
I think that the idea which is going to utilise the rubbish of Byker into pellets to create heating in the new Byker is a marvellous idea. Making the pellets and burning it is a much healthier method than dumping it.
The last step of all brings heat back to the people of Byker, back to the same streets and houses from which it came in its original form as waste.
Look what it's costing the council to run the rubbish to Tynemouth and Greenside. I think everybody will score out of this.
The house overlooks the reclamation plant, but the way it's built and the thought that's gone into it, it is in a depression at the bank of the river. The only thing you've got is the slim silver cylinder, the exhaust, against what used to be the incinerator at the top end of Byker, which was a big stone-built monstrosity, and it doesn't even protrude above the skyline which I can see through the window.
Well, I live quite close to the reclamation plant, approximately 200 yards, and we aren't affected in any way. As they say, we'll get cheap heating from it now, you know, it's a good idea.
One of the major points really is that it provides a facility for having a better standard of heating at a lower cost than individual systems would be. In some of the cases in Byker we have old age pensioners, you have people on low incomes. They perhaps wouldn't be able to afford to heat the houses to the normal standard otherwise.
I think it's clever, yes.
Day and night, Byker's waste is being reprocessed. It represents the solution by Tyne and Weir to an international problem faced by municipal engineers in many other cities. Byker is the first step in a new policy to make the best and most economical use of our waste material to provide some of the essentials of life. Today's waste, tomorrow's fuel.